Good day, folks. Today we are going to learn how to solve quadratic equations using the quadratic formula. Okay, and when you're all done today, you'll be able to solve a quadratic equation, much like the one you see here, using the quadratic formula. Now, our wicker note today is the word discriminant. Now, today we're going to be taking a look at what discriminant means. Now, think with me for a moment. If I say the word discriminate, what would that mean if somebody is discriminating? Well, one of the meanings of the word discriminate would be to, kind of discriminate or decide against something or decide for something, based on some different criteria. So, discriminating is similar to what we're going to do today. Today we are going to learn to discriminate against the type of solutions that we're going to see for quadratic formula using a process called the discriminant. With that in mind, let's go ahead and begin our lesson for today. Okay, our vocabulary word for today is the word discriminant, and we're going to come back to that here in just a little while. Let's begin today by looking back at the methods that we've done so far in order to solve for quadratic equations. First of all, we learned to solve them using graphing. Okay? We graphed, we looked to find the zeros of a function both on the graph and on a chart. Okay, so by a graph, by making a table, looking to see where the y value equals 0, by factoring and using the zero product property, by using the square roots, which we called extracting the roots, by completing the square, which we just finished. Well, today we have the final method, and that method is called the quadratic formula. So today we're going to learn how to solve quadratic equations using the quadratic formula. Now, in order to do so, always, 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 in your Cornell notes, I want you to put a little star off to the left side and make a little note. In order to solve for a quadratic equation, you must have the quadratic equation in standard form. So let me go ahead and circle that. It must be in standard form. In other words, it has to be like this: ax squared plus bx plus c equals 0. Here is our quadratic formula. So looking here, quadratic formula, provided we have the quadratic equation in standard form, this is our formula. Now, as of this point, I'm not going to focus on how that formula was derived. I'm just going to give it to you. Now, in college algebra, here, possibly next year, when you take college algebra, we're going to derive this formula. But for right now, I'd like you to just accept that this formula right here is the quadratic formula. Okay, now I want you to notice, you see that A right there? That's the same as that A right there. You see that B? That's the same as that B and that B. And that C right there is the same as that C. And you can't forget that A down there is the same as that A right there as well. So you're going to identify the A, B, and C and just take those integer values, A, B, and C, and they don't always have to be integers. You're going to take those real number values, A, B, and C, and you're going to plug them into the quadratic formula. Okay, well, let's go ahead and get started here. So, first of all, let's take a look at this problem right here. Here it is. What is my A value? Well, I don't see an A value, but what's always in front of there? If you said 1, I agree with you. So, A is going to equal 1. Okay, what's my B value? Well, my B value, what do we see it here? Well, yeah, it's a 3 right there. Okay, so B is equal to a 3. And what is my C value? Well, my C value is the 7, but don't forget, it's not just 7, it's also a negative 7. Okay, so it's negative 7. So what I'm going to do is I'm going to take each of these values, 1, 3, and negative 7. I'm going to take the 1 and I'm going to plug it here and down there. I'm going to take this 3 and I'm going to plug it there and there. I'm going to take this negative 7 and I'm going to plug it there. And then we're just going to use order of operations in order to simplify it. Okay, so let's start by plugging in the A value. So I plug in that A value, plug that 1 right there. and right here. Okay, next we're going to take the b value. I'm going to plug that in right there and right here. Okay, now notice what I did here. Notice how I put parentheses around what I substituted in. Notice each of the numbers here, especially under the radical. I put those parentheses there and here. Now I didn't do it here, but you know what? I probably should have, because remember that is negative, and then I plugged the 3 in there. So there's the parentheses there. All right, so what's left? Well, let's see here. We have our c value. So I plug the c value right in there. Now guys, we're going to just use order of operations, and we're going to simplify this. So underneath here, let's say we have 3 squared, which is 9. You have negative 4 times 1, which is negative 4, times a negative 7, which gives us a positive 28. So I have 9 plus 28. Out here I have a negative 3. Down there I'm going to have 2 times 1, or 2. Okay, after doing that, that's what it gives me. Now 9 plus 28, we're going to simplify that, and underneath the radical I get 37. Now, is there a perfect square in 37? No, there isn't. That's a prime number. So, guys, just leave it right there. So, at this point, let's go ahead and we're just going to put a colon right there and right there. Put your X and put it in set builder notation, and there's our final answer. Now, some of you may say, whoa, that's a pretty strange answer right there. You're right, guys, but it's an exact answer. So don't change these into decimals. Just leave them as exact answers, just like that. Okay, let's go ahead and try another one. So for this one here, let's see. Notice my a value is a 2. My b value is a negative 16. And my c value is a 27. Now remember, you need to always set it equal to a 0. So you can set it equal to 0. There's my 0. Now let's go ahead and plug it in. And your formula, let's go ahead and write the formula down. So it's opposite of b plus or minus the square root b squared minus 4ac all over 2a. That almost sounds like a song I used to know. And guys, it just so happens that there is a song that goes along with this, and when we get in class, we're going to practice singing that song just to help you remember the formula. All right, so let's go ahead and finish plugging stuff in. So it's going to be negative, parenthesis, I'm going to plug a negative 16 right there, plus or minus the square root of, it's going to be negative 16 squared minus 4 times 2 times 27 all over 2 times 2. Okay, now let's just try to simplify this using order of operations. So we end up with a 16 plus or minus. Now negative 16 squared is 256. Minus, and 4 times 2 times 27 is 216 all over 4, which gives us 16 plus or minus, let's see, that gives me the square root of 40. And at this point, guys, I'm going to go ahead and distribute that 4 to each part here, just like that. All right, now let's go ahead and simplify here. So it looks like this here is going to give me a 4 plus, and the square root of 40. Is there a perfect square in that? Well, let's see. 4 times 10. So yes, 4 is the perfect square, so that's going to be 2 times the square root of 10 all over 4. 2 goes into here once, 2 goes into here twice, so my final answer is going to be 4 plus or minus square root of 10 all over 2. And of course, we need to put that in set builder notation. So my final answer looks just like that. Now guys, I want you to realize that this problem would be very difficult to do if it weren't for the quadratic formula. That's why the quadratic formula makes it a very simple process to use that to find the roots of a quadratic equation. All right, let's move on, and we're going to talk about the discriminant now. The discriminant is this piece underneath the radical. Okay, so we're going to take a look at that radicand, the b squared minus 4ac. That is the discriminant. Now, as I was saying, the discriminant discriminates against the type of solutions we are going to have. So here's your definition for a discriminant. The discriminant is a part of the quadratic formula that you can use to determine the number of real roots for a quadratic equation. Okay, go ahead and pause that and get this definition down in your notes. Now let's continue that definition here. Now I want you to notice here, if you plug in your b and your a and your c, and if that value is greater than 0, that means you have two distinct real solutions. And that also means your quadratic, if you were to graph the quadratic function, it would cross the x-axis twice, looking much like this problem right here. Now, if your b squared minus 4ac ends up equaling 0, that means that quadratic function is going to come down and it's going to bounce off the axes and go back up. In other words, there's going to be a multiplicity of 2 situation there. In other words, you will have one distinct real solution. Now, what about if your discriminant is less than 0? Well, in that case, guys, you're going to have the square root of a negative number. Now, if your discriminant happens to be negative, that tells us right there that we do not have any real solutions. In the real number system, the number of solutions is it doesn't have any. But there are solutions, and these solutions are called complex solutions. In other words, the graph is going to be up here like this. It doesn't come down and cross the x-axis. It's going to be up here. So your solutions, you will have two distinct non-real complex solutions. And we're going to learn more about these complex solutions in a short time period in the next day or so. All right, folks, let's go ahead and take a look at this problem here. In looking at this question here, it wants to know how many solutions this quadratic equation has. Now, the first thing we need to do is I need to subtract this 12x to the other side in order to get it into standard form. Now, in looking here, can we identify what my a, b, and c value are? Well, yes. A we can see is going to be 1. B we can see is going to be negative 12. And C is going to be equal to a positive 36. All right, so now we're going to take each of these and we're going to plug these in. So for B, we're going to plug in that negative 12. For A, we're going to plug in that 1. And for C, we're going to plug in that 36, just like that. Now, we're going to use order of operations to simplify this. So let's plug things in, simplify it, and we get 144 minus 144. Okay, wait a second here. How did we get that? Well, what is negative 12 squared? 144. And then negative 4 times 1 times 36 is negative 144. So 144 minus 144 is what? Well, that's 0. Now look back at your notes. When the discriminant ended up to be 0, what does that tell us? How many solutions did we have? Well, if you said that we had one solution, then I agree with you. That is exactly right. So we have one real distinct solution. Okay, let's go ahead and take a look at another one, but I want you to do this time. So go ahead and pause it, and then we'll come back and talk about it here in a moment. Okay, now that you've worked through this, first of all, what did you get for your A, B, and C? Well, wait a second here. We have to do something first. We have to take this 12x and bring it over to the other side. So, what is this A? Well, looks like it's a 1. And what is the B? Well, yep, negative 12. And the C? Yep, I agree. It's going to be 40. So now you plugged each of these values in there just like so. And when you simplified it, you should have gotten this here. Notice that our discriminant was a negative 16. Because it was negative, what does that tell us? How many solutions? We have no real solutions, but that also means we have two complex solutions. Okay, because it is less than 0, we have two complex solutions. No real solutions, two complex solutions. For this next problem, folks, let's take a look at where we can see this in real life. Now, I'm going to work through this problem pretty quickly here, but it says an athlete on a track team throws a shot put. The height y of the shot put in feet t seconds after it is thrown is modeled by this equation right here. Now, can you see the a value? Right there. The b value? Right there. The c value? Yes, it's right there. Now, the horizontal distance x in between the athlete and the shot put is modeled by this equation. Okay, so we're going to come back and use this one later. We first need to solve for t using the quadratic formula. Then we're going to take that t value that we get there and plug it in here to determine just how far that shot put happened to go. So there's our problem. So let's go ahead and work through this. All right, so to start with, we identify our A, B, and C. We can see what our A is. I'm going to just put A above it like that. We can see what our B is. We can see what our C is. And we're going to take each of those, A, B's, and C's, and we're going to plug those into our quadratic formula. All right, and after plugging it in, this is what it looks like. Now, folks, I'm going to run through this quickly. As I said, we're going to go ahead and we're just going to plug it in. We're going to use order of operations. And we're going to simplify this out, and it turns out that we get two answers. We get t is going to be equal to a 1.77 and a negative 0.23. Now, guys, we're talking about time. Is it possible for the shot put to be in the air 1.77? Well, you betcha, that is possible. Is it possible for our shot put to be in the air negative 0.23? No, it isn't. Okay, so what does that tell us? Well, the time cannot be negative, so that means this one is out the door. So that means, and we're going to round this to the nearest tenth, so that means our shot put was in the air for 1.8 seconds. Now, how do we figure out how far it goes? We're going to take that 1.88 and we're going to plug it into this formula right here. Okay, and I got that, remember I got that formula from the problem 2 slides ago. We plug it in there and we simplify, and it tells us that shot put went about 52 feet. So remember to always write your answer as a sentence. So the shot put went about 52 feet. All right, well folks, let's just spend a little time reviewing, and then we're going to call this quits for today. I want you to look at the different ways that we've solved quadratics. We just finished the quadratic formula. Okay, the quadratic formula is modeled by what I show right here. Okay, last class period we looked at the complete the square, which is modeled by what you see right there. Prior to that, we looked at the extracting the roots, which is modeled by what is there. And prior to that, we solved quadratics using the factoring method, which is right there, or the zero product property, as I also called it. And then we started this chapter by graphing and creating a table, and we could see by which is the method that is modeled right there. We can see that it crosses the x-axis here and here, and that would help us find the roots to an equation. So with that in mind, guys, there are a total of 5 ways that we have used to solve quadratic equations. And no matter which method we use, you should always get the same answer. And that's what this slide right here shows us. Well, ladies and gentlemen, that's a wrap for today. Here's the assignment that we're going to be doing next time in class.